Ready for a deep dive today? We're tackling a paper that's really got people talking. And, well, the title kind of says it all. LLMs will always hallucinate, and we need to live with this.
Yeah, it's a bold statement. Really makes you think twice about the promises you sometimes hear about, the future of AI and all that.
I know, right? And you might be thinking hallucinations, like AI is seeing things. But it's a little more complicated than that.
Yeah, it's definitely not your typical ghost story. Basically, the paper says that these hallucinations, those times when an LLM spits out wrong or just plain nonsensical information, they're not just glitches, they're like baked into how these models work.
Okay, now we're getting somewhere. We always hear about these massive data sets LLMs train on, but what's actually going on under the hood?
Think of it like this. Imagine all that training data as a huge, massive library. Tons of information, right? But if you don't have a good system for organizing it, even the smartest LLM is going to have trouble finding the right book, let alone the exact page you need. What they do is they take all this text and break it down into these little pieces called tokens, kind of like turning a sentence into puzzle pieces.
So instead of getting the meaning of a whole sentence, they're just looking for patterns in these tiny pieces.
Exactly. They get really good at predicting what comes next in a sequence based on those patterns, but they don't actually understand the information the way we do.
So if you ask an LLM to write you a poem, it's not because it suddenly became some kind of artistic genius. It's just because it's seen a gazillion poems and knows how they're structured.
Exactly. And this is where things get interesting because the paper argues that this whole process of predicting and generating text, it's inherently prone to, well, making stuff up. Think about those autocomplete fails you see online. Same idea, just on a much bigger scale.
So even with crazy advanced LLMs,
Mm-hmm.
what are they called? Mamba and Jamba. I hear those are supposed to be lightning fast with this stuff.
Yeah, Mamba and Jamba, those are some of the big ones. And the paper uses them as prime examples. They're saying even with all their fancy architecture and being able to handle millions of these tokens, they still make these mistakes, these hallucinations.
Meaning it's not just about making them bigger and faster. There's something else going on here, something deeper.
You got it. And to really drive this home, the researchers have come up with this really interesting thought experiment. They call it the sentence from infinity, and it gets at the core of why these hallucinations might be impossible to get rid of completely.
The sentence from infinity. Okay, now you've got my attention. We're definitely coming back to that. But first, let's dig into the different types of hallucinations. Because, like you said, it's not always as simple as an LM and just making up a fact or something.
Right, and some of these hallucinations are trickier to spot than others.
Okay, so spill the tea. What kind of crazy stuff are we talking about here?
Well, the paper breaks it down into four main types, and each one has some pretty interesting implications for how we use and think about LLMs.
Okay, so the sentence from infinity, we're definitely coming back to that. But first, let's talk about the different ways these hallucinations can actually manifest.
Because it's not always as simple as, say, an LLM just making up a historical figure or inventing a scientific study.
Right, it's not always that obvious.
No, not at all. The paper breaks these hallucinations down into four main types. And each one, it has these different implications for how we interact with LLMs, how we use them.
Let's hear it. Lay it on me. What are these four types?
All right, so the first type is what they call factual incorrectness, which is honestly probably the easiest one to understand. This is when the LLM just gets a fact wrong, plain and simple.
Okay, so what, a typo in a textbook? Or recipe that's got the measurements all messed up?
Exactly. Think of it like that. Or, I don't know, imagine a history textbook that says the moon landing was in 1975 instead of 69.
Okay, so yeah, could be a relatively minor error, but I mean, depending on what it is, it could have some big consequences.
Absolutely. And that's, I think, why understanding these nuances is so important. Now, the second type, misinterpretation, that's where things get a bit trickier. It's not necessarily that the LLM is giving you false information. It's more like it's misconstruing your intent or the context of what you're asking.
So it's like, I'm trying to think of a good example. Okay, it's like you're asking it to explain a legal term, but you forget to tell it you need the historical context, not how it's used today.
Perfect example. The LLM might give you a perfectly valid definition, but it's totally irrelevant to what you're actually looking for.
Yeah, and I bet that's a real headache in fields like, law or medicine, where even a tiny misunderstanding could have huge consequences.
Oh, absolutely. High stakes. And speaking of searching for a needle in a haystack, that brings us to the third type, right? Needle in a haystack.
Right. having all the information in the world, but no clue how to actually find what you need.
That's it. It's like, imagine you've got this massive library, but there's no card catalog, no Dewey Decimal System, no search bar, nothing. You might know the answers in there somewhere, but good luck finding it.
Talk about frustrating. So in this case, the LLM, it might leave out crucial details or even mix up true and false statements, right? You end up with this story that sounds super convincing, but is actually total nonsense.
You hit the nail on the head. It's like it can create this very plausible, but ultimately misleading narrative. Dangerous stuff.
And then we come to the grand finale, the one everyone's talking about, the fabrications.
Ah, yes, fabrications. The LLM just making stuff up. This is the one that tends to grab the headlines. And honestly, it's understandable.
Yeah, I mean, that's some scary stuff. So it's not just like getting a date wrong. It's creating something entirely new, right?
Exactly. And here's the kicker. It often does it with this weird sense of confidence.
Like it believes its own lies.
Exactly.
Yeah.
So it can be really hard to catch. Think of it like the LLM is, I don't know, it's like it's writing a story, and sometimes it gets a little carried away, adds in details that have no basis in reality whatsoever.
So we've got the inaccurate, the misinterpreted, the missing, and the completely made up. Quite the cocktail of potential issues.
And the really tricky part is that they can all show up at the same time. You might have some perfectly good information mixed in with these hallucinations, so it's really hard to tell where the truth ends and the fiction begins.
And that's why I'm guessing the researchers are saying that just trying to fix these hallucinations by, I don't know, making the models bigger or giving them even more data, that's not necessarily the answer.
It's not that simple. It's about understanding what's happening under the hood, the underlying mechanisms that lead to these hallucinations. And that, my friend, brings us back to the sentence from infinity, that little thought experiment that kind of shakes the whole foundation of how LLMs process information.
Okay, you've been teasing this sentence from infinity thing all episode. It's got to be pretty mind-blowing to challenge these LLMs at their core, right?
It's a real head-scratcher. Remember how we talked about LLMs predicting the next word in a sequence, building those sentences brick by brick? Well, this thought experiment, it threw as a wrench in the whole process.
You're really building this suspense here. So how does it work?
Imagine giving an LLM a prompt, a simple one, something like, write a sentence, then tell it to count down the words from infinity.
Count down from infinity. Okay, yeah, now my brain's doing backflips.
Exactly. See, for us, it's just dot nonsense. Infinity isn't a number you count down from. But an LLM, stuck in its linear predictive way of thinking, it might not catch that.
So it'll just keep spitting out words, trying to follow the instructions literally.
You got it. And the paper actually gives some examples of how different LLMs handled this, and, well, it gets kind of funny. Some of them just get stuck in these endless loops, others generate these strings of words that make zero sense, all because they're trying to do the impossible.
Which, to be fair, is what the prompt told them to do. But it does make you realize how differently they think compared to us.
That's the whole point. It highlights this fundamental difference. And the researchers, they use this sentence from infinity to illustrate a really profound idea. They're saying even with perfect algorithms, even with infinite data, there are still going to be limitations baked into how these LLMs work, how they process information, limitations that might make these hallucinations completely unavoidable.
So no matter how much we tweak and train these LLMs, there are going to be some blind spots.
It's like, imagine trying to reach the horizon. No matter how far you go, it's always just out of reach. Kind of a mind-bending thought, isn't it?
So where does that leave us? Are we just supposed to throw our hands up and accept that these hallucinations are going to be part of the package?
It's not all doom and gloom. The researchers do talk about some pretty cool techniques that are being developed to, if not eliminate, then at least try to mitigate these risks. Like, there's something called chain of thought prompting. Basically, you force the LLM to slow down, break down its reasoning process step by step, kind of like showing your work in math class. Makes it easier to spot any errors.
Okay, so if we can see how they're getting to an answer, we might be able to catch those hallucinations before they turn into a problem.
Exactly. And then there's retrieval augmented generation, which is basically like giving the LLMs access to a whole bunch of external knowledge bases. So they're not just relying on their training data anymore. They've got these fact checkers on hand.
Which seems absolutely crucial, especially if we're talking about LLMs being used in, like, medical diagnoses or legal advice.
Absolutely. High-stakes situations need some serious backup. But even with these advancements, the paper still argues that getting rid of hallucinations entirely might be, well, impossible. It's like think about language itself for a second. It's inherently ambiguous. Even we as humans, we misinterpret each other all the time.
So you're saying that the very thing that makes LLMs so powerful, the way they can use and understand language, that might be their Achilles heel.
It's definitely something to consider. It's not about abandoning LLMs altogether. They obviously have incredible potential. But we need to be realistic, right? Understand their limitations. Use them responsibly, not blindly.
It's like having a super-powered tool, amazing potential, but you got to be careful, know how to handle it.
Exactly. And this paper, it's a good reminder that as impressive as LLMs are, they're still just tools. It's on us to use them wisely.
This has been a fascinating deep dive, to say the least. A little unnerving at times, I'm not going to lie, but definitely eye-opening.
The future of LLMs, it's full of possibility, but the more we understand these models, the better equipped we'll be to navigate whatever comes next.
So to everyone listening, don't be afraid to ask tough questions. Think critically about the information you come across. And hey, if an LLM tells you something that seems a little too good to be true, maybe double check it. Until next time, keep exploring and stay curious.